So I am recording. Please feel free to raise your hand and stop me. I could always pause and go back and re-record. Um, I already made one video. I'm going to make a second video explaining other questions. So on this first section of this part two of the practice midterm, we are multiplying fractions. And how do we do this? We need a factor to be able to get multiplication. That way we could cancel things out. Okay. So just a quick review. If I had like let's say 2 plus 4 divided by 2, you cannot cancel out the 2's. But if you had 2 times 4 divided by 2, then you could cancel out the 2's and your answer would be 4. Okay. Right here, you cannot. 2 plus 4 is 6. 6 divided by 2 is 3. If you canceled it, you'd have the wrong answer. The answer is not 4, it's actually 3. But when you have multiplication, you can cancel. Anyway, that's just a little reminder that you need multiplication in order to be able to cancel things out. So this is why we are going to factor to get that multiplication to then be able to cancel. So if we look at the numerator of the first fraction, could we factor this? And the answer is yes. How? With the difference of two perfect square terms. So if you square root both of them, you're going to be able to plug in those answers into your factored form answer format, which would be a binomial times a binomial. So the question is, what is the square root of 16y squared? What's the square root of 16y squared? 4 with the y. So you put a 4 and a y on both first parts of each of those binomials. And then you ask yourself, what is the square root of 1? Square root of 1 is 1. So you're going to put a 1 as the second part of each of those binomials. Now notice that this is a binomial. It's not a trinomial. In other words, there is no middle term. So if there's no middle term, that means that they have to cancel out. That means that these binomials have to be conjugates of each other. In other words, one's a plus sign, one's a minus, and it doesn't matter which one's which, as long as they're opposite signs. Anyways, that's how to factor a difference of two perfect square terms, okay? Now, how about this denominator of the first fraction? Is there anything to factor it? The answer is no. There is no GCF, there's nothing to do, so I'm just gonna rewrite it 16y minus 1. We have multiplication, we have the other fraction. Up here, is there anything to factor? No, but then again, look, it's out of order. We usually have our y term first and our constant at the end. So we need this y term to be first. So this is what I would do. I would circle it just so you could visually see that you're going to move that to the front of this positive 1. So you're really going to have a negative 16y with a positive 1 at the end. So it's the same thing, we just rewrote it, okay? And then on top of that, well, maybe I should rewrite it up here, look. Negative 16y and plus 1. Let me erase that over here. Now, there's a reason for that. Check it out. Up here, as I move it down to here, I am going to factor out a negative 1. That way, this negative 16y on the inside will be what? Positive 16y. That's exactly right. So positive 16y. And if I do pull out a negative 1 from here, then I'll have a negative 1 right there. Okay. Do you guys see why I pulled out a negative 1? Because this binomial is now identical to that binomial, which will be able to cancel. But before we do that, let's write this last one down here, the denominator of the second fraction. There's nothing to do. We're just going to rewrite it 4y minus 1. Nothing to factor. It's in order. Everything's good. So now that we have pure multiplication, you could cancel things out. Now, it's incorrect to say, oh, I'm going to cancel this 4y with that 4y. No, it's not. You can't do that. Why? Because there's a plus sign, there's a minus sign. But it is okay to cancel out the entire binomial if the same exact binomial is up on top, which it is. The 4y minus 1 will cancel with the 4y minus 1. And also this 16y minus 1 cancels out with this 16y minus 1, the entire binomial with the entire binomial. So what is left? You have the 4y plus 1 times that negative 1. So you're going to distribute and you'll have your final answer. The answer is negative 4y minus 1. There you go. This is a 3-point question. Let me give you an example of how you could probably only get 1 point. Maybe you just factored one of them correctly, or maybe you factored 2 of them correctly, but you didn't cancel correctly, so that you get 1 point. Or maybe you factored correctly, then you did cancel these 2, but you forgot to cancel those 2. Maybe you get 2 points instead of 3. showing all your work, getting that correct answer. That's how you get 3 points. And it has to be on paper. Okay. You won't get any points if you don't show your work. So you have another one to practice here. And if you wanted to double check that, all you got to do once you get your answers is go to Google Classroom and see the answer there. So let's move on to, let's do this one right here. This next one, same concept, but we are dividing instead of multiplying. But we should all remember that division is really multiplication as long as you flip that second fraction, okay? So before flipping it, I mean, I already drew my fraction bar and I am gonna flip it. But before doing anything, how about we start factoring? Just like before, you need multiplication to be able to cancel. So if you look at this numerator of the first fraction, which we are not gonna flip, the a value is 1, and it's a quadratic trinomial. So when you have that situation with a quadratic trinomial with no number in the front, you might be able to factor by putting that x right there and the x right there, because x times x is x squared. And what's the process? The process is to think what times what is the c value that if you combine together is a b value. So you might want to make a list. How could we get negative 24 with multiplication? I'm going to start by negative 1 times 24, or negative 2 times 12, or negative 3 times 8, or negative 4 times 6. Those are all the possible multiplications to get negative 24 besides changing signs. So once you make your list, then you go back and start adding the numbers together, combining them, and seeing which pair of numbers actually gives you the middle value, positive 2. So in this case, that gives you 23, this gives you 10, this gives you 5, this gives you a positive 2. And you don't have to worry about changing any signs. You just put that -4 right there and that +6 right there. And it doesn't matter the order. You could have put the +6 first and the -4 second. Anyway, let's do the same for this bottom one. What times what is the c value that if you combine together is a b value? You might want to make a list. I'm going to make a list of the multiples of negative 12, negative 1 times 12, negative 2 times 6, negative 3 times 4, and that's about it. Now, which pair of numbers combines together to give us the middle term 4? That will be the negative 2 plus the 6. That gives us a positive 4. Okay, so this is the correct pair of numbers that we want. Again, this is the setup. You could put x and x, and you simply put this pair of numbers into those blank spots. So you're going to put the -2 right there and the +6 right there. It doesn't matter the order. Now, this other fraction that I'm going to end up flipping, as I flip it, as I move this bottom one up to the top, I might as well factor whatever I can. And this binomial, I could pull out a GCF. So I'm going to at least pull out the 3, pull out a 3 from both of these as you move it up. So pulling out the 3, 3 times what gets you back to a 3x x. And then how about 3 times what gets you back to a -6 -2? There you go. So we have factored the GCF of 3 out of this denominator, which is now the numerator because we moved it up. And now this guy, you could think of this also as a difference of two perfect square terms as you move it down and do the square root of each. Or you could think of it as parentheses, x. And you think what times what is the 16, negative 16, that if you add together is a middle term, which is nothing. So that would be a positive 4 and a negative 4, positive 4 and a negative 4. So now that we've factored, now we do have a bunch of multiplication. Multiplication up there, multiplication down there, multiplication right here, multiplication right there, a bunch of multiplication. We can now cancel things out that are identical up on top and on the bottom. So the x minus 4 cancels with the x minus 4. This x plus 6 cancels with the x plus 6. And this x minus 2 right here and that x minus 2, those also cancel out. Dang, a lot of canceling. So what's our final answer here? We have a 3 up on top and an x plus 4 on the bottom. And that is it. That's our answer. And again, I have answers posted on Google Classroom that you guys could check out if you wanted to verify that. So now that you've seen this one, you should be able to go back and be able to do that one on your own and verify it on Google Classroom. I'm moving on to this next question, which is adding and subtracting fractions. I want to go for this one. What do we need to be able to add or subtract fractions? Common denominator, right here, common denominator. So what is the LCD of 5, 6W, and 10W? Anybody? LCD, lowest common denominator. 30 with a W. 30W. Okay. 5 could be changed to a 30W, 6 could be changed, 6W could be changed to a 30W, and 10W could be changed to a 30W. Okay. So what we're going to do is we're going to rewrite all three fractions, but with that LCD of 30W, 30W, 30W. You need to do this to be able to add or subtract fractions. Now, if it were an equation, like if you had equals 5 or equals 0, then you could get rid of fractions by multiplying everything by the denominator of the fraction you want to get rid of. But right here, this is not an equation. You actually need to think about the LCD, change all of your denominators to that LCD. So how do you change the 5 to become 30W? Well, 5 times 4, no, not 4, 5 times 6 W will give you the 30W. So you multiply the top as well by 6W and you get a 6W up here. And then 6W times what gets you a 30W? Just the number 5. Just the number 5, okay? So you're going to go times 5, you get a 25 up here. And last but not least, what do you do to the 10W to get a 30W? You multiply just by 3, no W's, so you get a 9 right there. And of course, we had a minus sign between the first two fractions, so we still have a minus sign. And we have a plus sign between the other two fractions, so we still have that plus sign there. So now that you have a common denominator, you're able to add them all up and put them over that common denominator 30W. So what is 6W? Take away 25 plus 9. Well, you can't even do the 6W with numbers, but you could do the minus 25 with the plus 9, and that'll be a minus 16, correct? So what I really have is the 6W minus 16, and it is over 30W. Now, that is your answer. However, whenever you have a fraction as an answer, you're supposed to try to simplify it, reduce it. And in this case, you could take that 6W minus 16 and you could divide it. You could pull out a GCF of 2. That way you'll have a 3W minus 8 inside over the 30W. Bless you. And why do we do that? Because now we do have multiplication and multiplication, which means you could cancel out the 2 with the 30 and get a 15. So your final answer should be 3W minus 8 over 15W. Fun stuff. So again, you could verify your answers on Google Classroom. And now that you saw that example, you should be able to do this example. Let's flip this paper over and finish off this second part of the practice midterm. Oh, what the heck? So on the previous video, I explained this one. So I'm going to jump to this guy over here. So we are going to add these two fractions up on top. And in order to add the two fractions, we need a common denominator. So we're simply going to put these together with multiplication to get the common denominator. So I'm going to rewrite these two fractions. I want to rewrite them right here. One fraction plus another fraction. But instead of this denominator, I'm going to put both of these together as an LCD, put both of these together as an LCD. So I will have the 3x minus y times 2x plus y. And I'm going to write that on both of them. So then we're going to ask ourselves, what do we do to this first denominator, the 3x minus y, to get a 3x minus y times 2x plus y? Well, obviously going to multiply by the 2x plus y. So if you multiplied by 2x plus y on the bottom, you also have to multiply by 2x plus y on the top. And you're going to have to distribute right there. 2 times 2x, 2 times 2x is 4x, and 2 times y is 2y. And then you ask yourself, what do you do to the 2x plus y to get a 2x plus y times 3x minus y? Well, you're going to have to multiply by 3x minus y. So you multiply both top and bottom by 3x minus y, 3x minus y. And if you distribute the 1, you're going to get exactly that, 3x minus y. So now that we have a common denominator, now we're able to actually add these two fractions together. And the answer will be over that common denominator, 3x minus y times 2x plus y. Let's just add the top with the top. So we really have 4x plus 3x. That's a total of 7 x's. Then we also have the 2y plus minus y. So what's 2y plus a negative y? That's just a 1 positive y, or just plus y. You don't need the plus 1 in front of it if you don't want it. I'll erase it. So there you go. So I hope we understand that this top part of our complex rational expression gave us this answer. And we still need to divide it by, this guy. So that answer is still over this guy, 1 over 3x minus y. So we really have this fraction divided by this fraction. And it's better to write that out horizontally instead of vertically. So here it is. We have the 7x plus y over 3x minus y times 2x plus y. That was our answer to the numerator. And it's divided by, but I'm going to do it as a division sign, that other fraction, 1 over 3x minus y. Now, why would I do that? Because the division is going to change to multiplication as long as you flip the second fraction. So you get a 3x minus y up here and a 1 right there. The first fraction stays the same, 7x plus y over 3x minus y times 2x plus y. And now that we have factored everything possible, is there anything that we could cancel? Yes, this entire binomial 3x minus y cancels with that 3x minus y, leaving us our final answer, 7x plus y over 2x plus y. Now the question is this our final answer, or could we do anything else? If you're thinking, oh, we could cancel the y's, that'd be incorrect because of the plus signs. So this is our final answer. So number 10, there's your answer, 7x plus y over 2x plus y. This is a 3-point question. That took a lot of work, right? So maybe 1 point for getting this top answer, another point for doing this correct setup of flipping this over with multiplication, and a total of 3 points if you do all this with the correct answer. Moving on to graphing rational functions. It says state the asymptote, the domain, and the range. So let's first understand the form that we need to have memorized. So I hope we remember that h is always inside parentheses or square roots. It's always inside something being subtracted from x. So you have x minus h at the bottom in this case, because h is always being subtracted from x. Now, normally we have a out in the front, but since if you had any type of number times a fraction with the 1 up here, you would simply multiply the a times that 1. So the a would technically end up on top. And then you also have the plus k at the very end being added or subtracted on the outside, okay? So this is your function that we should be familiar with. So you can clearly see that the a value is -3, the h is actually -2, the k is actually -5, okay? And the things that it asks for is the asymptotes. So let's begin by stating the asymptotes. And I hope we remember that the asymptotes, the vertical asymptote, the one that runs up and down, is x equals h. And the horizontal asymptote is y equals k. So let's state both of those. The vertical asymptote, x equals -2. But what does that actually look like? You go to the x-axis, you go to -2, you put a dot there, and then you draw a vertical line running right through it, okay? And then for the y equals k, that's a horizontal asymptote, so y equals -5 in this case. You go to -5, 1, 2, 3, 4, 5, and you draw a horizontal asymptote right through that y value of -5. So here's your vertical, x equals -2. Here's your horizontal, y equals -5. Now, after that, you could do a quick sketch and realize the a value being negative is kind of like a negative slope. It's going to have the same end behavior as a line that has a negative slope. It ends up here on the upper left and down here on the lower right. So your graph will be along these asymptotes up here and down here. But to be more precise, what you should do to get actual coordinates is to make an XY table and plug in some numbers that are on the left side of the vertical asymptote and some numbers that are on the right side of the vertical asymptote. And you can pick any numbers you want. For example, um, let's do the left side. This is -1, -2. How about -3? Would that work out nice if I plug in a -3? Check it out. Plugging in a -3 right here, -3 plus 2 is -1. And that works out great because a -3 divided by a -1 is actually a +3, and +3 minus 5 is -2. So when I plug in a -3, I actually get out a -2, and that's a nice coordinate. Let's graph that coordinate: -1, 2, 3, -1, 2, and you end up with a point right there at -3, -2 from the origin. Okay. Now think about this. Would it be good to plug in a -4? Maybe, maybe not, or maybe a -5, or maybe a -6. If we try -4 right there, -4 plus 2 is -2, and -3 divided by -2, I end up with a fraction. That's not nice. So let's try the next number, -5. -5 plus 2, that's -3, and that works out beautifully. A -3 divided by a -3 is a +1, and +1 minus 5 is a -4. So when you plug in a -5, you get out a -4. Let's go to that coordinate: -1, 2, 3, 4, 5. 1, 2, 3, 4, and you'd end up with a dot right there. So we should know that our graph is running through those 2 points and it infinitely approaches the asymptote. You're going to draw it like if it's actually touching, even though you know it never actually touches, just infinitely approaches. And it also goes in this direction as well. You draw it like if it's actually touching, even though it never actually touches, it just infinitely approaches. Now we also need to have it down here, and you could map those coordinates to the other side, or you could continue with the XY table and simply plug in some values that are on the right side of this vertical asymptote. How about like -1, or like 0 or +1, right? -1, 0, or +1. Let's see which ones work. Maybe they don't all work. -1, how would that work? If I plug in a -1, -1 plus 2 is +1. -3 divided by +1 is -3. And -3 minus 5 is -8. So when you plug in a -1, you get out a -8. It works out great. And it rhymes. Okay, so let's go to -1, -8. -1, -8 would be right here, 2 from the edge. And we could try plugging in 0, but 0 plus 2 is 2, and 3 divided by 2 is not a nice number. So how about 1? Plug in a 1 right there. That'd be 1 plus 2 is 3. 3 with the -3. -3 divided by 3, that's a -1. -1 minus 5 is -6. So when you plug in a 1, you get out a -6. So that's another nice coordinate. Let's go to 1 and -1, 2, 3, 4, 5, 6 right there. And of course, your graph is going through those 2 points and it infinitely approaches the asymptote, and it infinitely approaches the asymptote. So there's your perfect graph with actual perfect coordinates: -3, -2, -5, -4, -1, -8, and +1, -6. That is as detailed as you could get. So what else did it ask for? The asymptotes, we wrote them down. We used them to graph. We actually came up with actual points. It also says to state the domain and range. So the domain is x equals all real numbers because it does go to the left forever and to the right forever, but it cannot be that asymptote value of -2. So you would say, but x cannot be -2. And same thing with the range. The range are your y values, and it goes up forever and down forever, but there's that asymptote y value that your y cannot be, which in this case is -5. So the range is y equals all real numbers, but y cannot be that asymptote value of -5. So I hope this helps. There's 2 more practice problems. You could check your answers on Google Classroom. And let's move on to the last one. I'm gonna go for this middle one right here. Okay. So this is a 4-point question and it's an actual equation. So an equation, I like it even better than an expression because if you had like 3 fractions that you had to actually add or subtract, you need a common denominator. And when you have an equation, when you have an equal sign, you don't need to get a common denominator. You could just start getting rid of fractions by multiplying everything by the denominator of the fraction that you want to get rid of. So if you're like, man, I don't want this fraction. Okay, multiply everything by what? The denominator x plus 3. But it's not just this fraction that you're multiplying it by. You're going to multiply this by x plus 3. You're also going to multiply this by x plus 3. Multiply everything by the denominator of the fraction you want to get rid of. So yes, that first fraction disappears. You just have a nice, beautiful x. How about this middle term? It's no longer a positive 2x. Positive 2x times x is a positive 2x squared. Positive 2x times 3, that's a positive 6x. You now have the equal sign. And over here, these guys actually cancel out as well. So you end up with a nice, beautiful x minus 4 on the right side of the equal sign. So you should all notice that you have a quadratic equation. Now, when you have a quadratic, set it equal to 0. That way, you might be able to factor it and use zero product property to split it and solve it. So before even moving everything over to one side, I want to actually combine that x with those 6 x's. So I really have a 2x squared plus 7x equals x minus 4. And now I'm going to worry about moving everything to one side and setting it equal to 0. So subtract x, you're going to end up with 2x squared plus 6x equals negative 4. And from there, we're going to get rid of that negative 4 by adding 4 and adding 4. So you end up with 2x squared plus 6x plus 4 equals 0. Now, at this point, some of you might be thinking, oh man, this is going to be that long factoring method because the a value is not 1, where I'm going to have to go a times c and then get that answer, make a list of the multiples of that answer. But remember, this is an equation, which means you could do whatever you want to an equation as long as you do it to both sides, as long as you do it to every single term. So look at this. There's a 2, a 6, and a 4. They're all divisible by 2. So to make life easier, just divide by 2, divide by 2, divide by 2, divide by 2. And you're going to have your new quadratic equation that is simply an x squared plus 3x plus 2 equaling 0. Now at this point, there's no more number in the front. There's an a value of 1, which means that maybe you could factor this old school method of what times what is c, that if you combine together is b. You might want to make a list. What times what is 2? There's only one combo, 1 times 2. And if you add those together, it really does give you 3. So there you have it, a plus 1 and a plus 2. It's equal to 0. So now that you have something times something equals 0, that first something could be set equal to 0. So the x plus 1, that could be equal to 0. Or the second something, x plus 2, that could also be equal to 0. This is called the zero product property. And if you solve both, minus 1, you get x equals negative 1. And if you solve the other one, minus 2, x equals negative 2, you get the other answer. However, in the notes, it says not only to solve it, but to also verify your solutions. You could go back and plug in the negative 1 into every single x, and doing the math and seeing if it's a true statement that the left side equals the right side. What I would do is just plug it into the denominator and make sure you don't end up with 0 in the denominator. Like, let's say one of these answers would have been x equals negative 3. When you plug it in, the negative 3 plus 3 would end up being 0. That would make it undefined. So that means that x equals negative 3 is an extraneous solution. Now that doesn't happen here. So right here, you actually have both of these answers as part of your answer, but you got to make sure that you don't end up with 0 in the denominators. So negative 1 right there will not give you 0. A negative 2 will not give you 0. So you're good to go. Both of those answers are correct. And once again, you could double check your answers on Google Classroom. So no excuses, guys. You have practice, you have answers to double check. Let's get ready for this midterm. We're going to have the first half of the midterm tomorrow, the second half the next day.